Hello, my phenomenal viewers, and welcome on to this episode. On today's episode, we will be answering this GCE 2025 question 3. The question reads: a discrete random variable x has the following distribution. So, this is the probability distribution of this discrete random variable x. When x is equal to 1, the probability of x is equal to 1 is 1 over 5. When x is equal to 2, the probability of x is equal to 2 is c. When x is equal to 3, its probability is 3 over 10. When x is equal to 4, its probability is k. When x is equal to 5, its probability is 3 all over 20. And the question continues. Given that probability of x is less than or equal to 2 is equal to 9 divided by 11 times probability of x is greater than 2, find the probabilities c and k, these two probabilities. Then B part of the question says, show that the expectation of x is 11 over 4. C, find expectation of x squared and the standard deviation. So as the question has said, x is a discrete random variable. So what does it mean by x being a discrete random variable? X is a discrete random variable means that x can only take integer values. Like is x can only take whole numbers. X is not continuous. So x cannot take values like 1.5, 2.5, and so on and so forth. X can only take whole number values. So that is what it means by x being a discrete random variable. So now the question has given us this probability distribution table, and what we need to know is that the summation of all of these probabilities must be equal to 1, because these are the different possible values that s can take with respect to this distribution. S can take either 1, 2, 3, 4, or 5. So these are the different outcomes, and these are the different probabilities for these different outcomes. So when we sum all of these different probabilities, we must have 1. Remember, I said that probability can never exceed 1. So when we sum all of this, since all of these different outcomes are collectively exhaustive, so when we sum all of these different probabilities, we must have 1. So solution: summation from x is equals to 1 up to 5 of p of x is equals to x must be equal to 1. So mathematically, this is how it is written. Now I need to sum all of these probabilities and equate it to 1. So this implies 1 all over 5 plus c plus 3 all over 10 plus k plus 3 all over 20 must give me 1. So this implies, since the highest denominator here is 20, I'm going to make all of the different denominators to be 20 as well. 1 all over 5 is the same as 4 all over 20 plus 3 all over 10 is the same as 6 all over 20. When I multiply 3 by 2 and 10 by 2, I'm going to have 6 all over 20. Then plus 3 all over 20 plus c plus k plus c plus k is equal to 1. So this implies 4 plus 6 gives me 10 plus 3 gives me 13. So I have 13 on 20 plus c plus k to be equal to 1. So this implies c plus k is equal to 1 minus, when 13 on 20 plus is equal to, say, it becomes negative, minus 13 on 20. So this implies c plus k is equal to 1 minus 13 on 20 is the same as 20 minus 13 divided by 20, which gives me 7 on 20. 7 on 20. So this shows that I have c plus k to be equal to 7 on 20. 7 on 20. So I call this my equation 1. So this is the first equation that I've obtained. Now the question further says that the probability of x is less than or equal to 2 is equal to 9 divided by 11 times the probability of x is greater than 2. So the probability of x is less than or equal to 2 is equal to probability of x is equal to 2 plus probability of x is equal to 1. So this shows that from probability of x is less than or equal to 2 is equal to 9 all over 11 times probability of x is greater than 2. This implies we have 1 all over 5 plus c. Like I've explained, this probability simply means we sum probability of x is equal to 2 and probability of x is equal to 1. This is equal to 9 all over 11 into probability of x is greater than 2 simply means probability of x is equal to 3 plus probability of x is equal to 4 plus probability of x is equal to 5. So this gives me 3 on 10 plus k plus 3 on 20. So this implies that we have 1 all over 5 plus c is equal to 9 all over 11 into, this is the same as 6 all over 20 plus 3 all over 20. That gives me 9 on 20. 9 on 20 plus k. So expanding this other way, if I multiply top and bottom by 4, I'll have 4 on 20. I want to make everything to have the denominator of 20 plus c would be 9 times 9 gives me 81. 11 times 20 gives me 220 plus 9k on 11. 9k on 11. If I multiply all through by 11, this implies I will have 44 on 20 plus 11c to be equal to 81 on 20 plus 9k. And I multiply all through by 11, this is what I'm going to have. So this shows that I will have 11c minus, when 9k crosses and comes this way, it becomes negative 9k to be equal to 81 on 20 minus 44 on 20. That gives me 37 on 20. So that gives me my equation 2. That gives me my equation 2. And my equation 1 this way is c plus k is equal to 7 on 20. So I have these two equations in terms of c and k for me to solve simultaneously. So I want to solve simultaneously and I want to eliminate c. So if I multiply equation 1 by 11, I'm going to have, multiplying equation 1 by 11, I'm going to have 11c plus 11k to be equal to 77 all over 20. So this is equation 3. 77 all over 20. So if I now take equation 3 minus equation 2, that gives me equation 3 minus equation 2 gives me 11k minus negative 9k gives me 20k to be equal to 77 on 20 minus 37 on 20. That gives me 40 on 20. That gives me 40 on 20, which is 2. So this implies that k in this case would be 2 on 20, which is equals to 1 all over 10. So it shows that the probability k is 1 all over 10. Now with this value of k, which is 1 all over 10, I can now substitute it into equation 1 to determine the value of c. So from equation 1, this implies that c is equal to 7 all over 20 minus 1 all over 10. So this implies that c is equal to 7 all over 20 minus 2 all over 20, and this gives me 5 on 20, which is the same as 1 all over 4. So therefore c is equals to 1 on 4, which is a quarter. So it shows that the values of k and c are 1 all over 10 and 1 all over 4 respectively. So K is equals to 1 all over 10 and C is equals to 1 all over 4 respectively. So this is how you solve the A part of this question. If the A part of the question has been understood, let us move to the B part of the question. Now, the B part of the question has asked us to show that the expectation of x is equals to 11 all over 4. Now, for you to determine the expectation of this discrete random variable, you simply take x and multiply it with its probability. You take x multiply with its probability. You take x multiply with its probability. You take x multiply with its probability. Take x and multiply it with its probability. And at the end, you sum all of the different values that you are going to obtain. That is going to give you the expectation. So mathematically, expectation is equal to summation from x is equals to 1 up to 5 of x times probability of x is equals to x. So this is what I mean. And this becomes 1 times its probability, which is 1 all over 5, and x is 2 plus 2 times the value of c. C is 1 all over 4, 1 all over 4 plus 3 times 3 all over 10 plus 4 times the value of k is 1 all over 10 plus 5 times 3 all over 20. So this gives me 1 all over 5 plus 2 all over 4 plus 9 all over 10 plus 4 all over 10 plus 15 on 20. Now I'm going to make all of these denominators to be 20. So for me to do this, for this first fraction, I'll simply multiply 1 by 4 and 5 by 4. That gives me 4 on 20 plus, for this I'll multiply by 5. I have 10 on 20. This I'll multiply by 2. I have 18 on 20. This by 2 as well. 8 on 20. Then this is already having a denominator of 20, so I just maintain it like that. 15 on 20. When I sum all of this, 4 plus 10 plus 18 plus 8 plus 15, I'm going to have 55 on 20. So my expectation EX is equals to 55 on 20. 5 can go into 55 11 times and 5 can go into 20 4 times. So it shows that expectation of this distribution, or the expectation of x, is 11 on 4, which is the same as the value that the question gave us. So the question asked us to show that the expectation of x is 11 on 4, and we've obtained the 11 on 4. So we've proven that the expectation is 11 on 4. So if the B part of the question has been understood, then the C part has asked us to determine the expectation of x squared and the standard deviation. Expectation of x squared and the standard deviation. So the expectation of x squared is equal to summation from x is equals to 1 up to 5 of x squared times the probability of x is equals to x. So for us to have the expectation of x squared, we simply take the value of x, we square it, and we multiply it with its corresponding probability. So this gives us 1 squared times 1 all over 5 plus 2 squared times c, which is 1 all over 4, 1 all over 4 plus 3 squared times 3 all over 10 plus 4 squared times 1 all over 10 times 1 all over 10 plus 5 squared times 3 all over 20 times 3 on 20. So this gives me 1 squared times 1 all over 5 gives me 1 all over 5 plus 2 squared times 1 all over 4 gives me 4 on 4 plus 3 squared times 3 on 10, that gives me 27 on 10 plus 4 squared times 1 all over 10, that gives me 16 on 10 plus 5 squared times 3 all over 20. That gives me 75 on 20. So this becomes, making the denominators to be 20 as well. I'm going to have 4 on 20 plus 20 on 20 plus 54 on 20 plus 32 on 20 plus 75 on 20. So this gives me, this is this plus this plus this gives me 90. That is 54 plus 32 plus 4. 4 plus 54, that is 58, plus 2 gives me 60, plus 30 gives me 90, then plus 20 gives me 110, plus 75, that gives me 185. So I have 185 divided by 20. So this is the expectation of x squared. 185 divided by 20. 5 can go. 5 goes into 18. 3 times remainder. 3 into 35. 7 times divided by 4. So this is the expectation of x squared. So the C part of this question has asked us to calculate the standard deviation, which is simply a measure of how spread out the recorded values of x are from the expectation or from the mean value. So if a distribution has a high standard deviation, it simply shows that the recorded values of x are far away from the expectation or from the mean value. And if the standard deviation is small, it shows that the recorded values of x are very close to the expectation or the mean. Now, for us to obtain this standard deviation, we need to first of all calculate what is called the variance of x. And the variance of x is calculated using this formula. Variance of x is equal to expectation of x squared minus expectation of x all this squared. So the expectation of x squared, we had calculated it earlier and we obtained 37 all over 4. The expectation of x, which is the mean, we have 11 all over 4. So we just need to substitute these values in here to obtain our variance. So this becomes 37 on 4 minus 11 on 4 squared. So this gives me 37 on 4 minus 121 on 16. Making this fraction to have a denominator of 16, I just need to multiply by 4. That is, multiply the numerator by 4 and the denominator by 4. This gives me 148 on 16 minus 121 on 16. And this gives me 27 on 16 to be the variance of this distribution x. So since we've obtained the variance, we can now obtain the standard deviation, because the standard deviation of any distribution is simply the square root of its variance. So standard deviation is equals to square root of variance. So this implies we're going to have the square root of 27 divided by 16, and this gives me square root of 27 is 3 over 3 divided by square root of 16, which is 4. So this is the standard deviation of this distribution. So this is how we obtain the standard deviation. Okay, if you liked this video, please help me and share so that it can get to many students as possible. And if this is your first time coming across any of my videos, please do not hesitate to either follow me or subscribe so that anytime I upload videos like this one, you would be notified. And thank you for watching. Stay blessed.